So this is going to be part 2 of us just solving. So we're going to leave off here this question. So you have to find the value of x. So after seeing the solution, the method was pretty simple. So here what we have to do is we just take sine inverse 5 by x as a. So sine a will be 5 by x. And then you take sine inverse 12 by x equals to b. Sine b equals to 12 by x. And then we have sine a here. So there are two values. This is a plus b equals to pi by 2. Again, so if we just took sine, so just a is equals to pi by 2 minus b, you just take sine on both sides. So sine a equals to cos b. So sine a is equals to under root 1 minus sine square b. Sine a is equals to 5x, which is equals to under root 1 minus sine square b, 1 minus 144 upon x square. 5x equals to under root x square minus 144 upon x square. So you have 25 upon x square, which is equal to x square minus 144. So 25 x square is equals to x4 minus 144 x square. So 169 x square equals to x4. So x square equals to 169, which is just plus minus 13. X equals to minus 13 is rejected, so the answer is x equals to 13. That's the answer. X is equals to 13 because of this. X value is 13. So now we have another value. So now we need to do this here again. So we have sine of sine inverse of 2 sine inverse 0.8. 2 sine inverse sine 0.8. This is directly 1.6 because ये रेंज के अंदर है. ये डिग्रीज में नहीं, डिग्री. This makes it interesting. ये 0.8 रेडियंस दिया है ना खाली. So the answer here should be 15. Is it 0.8? To sine inverse sine 0.8. Is this 0.8 degrees? This is 0.8 radians. This is 0.8 radians. Then also it should be fine. No, we have sine of 2 sine inverse 0.8. How are we getting this as 0.96? We shouldn't. No, that's the whole point. Okay, so you have sine inverse 0.8 here. Sine inverse. So this is 2 sine inverse x. So this is what? So this will be equals to sine inverse 2 into 0.8, 2 into 0.8, 2 into 0.8 under root 1 minus 0.8 square. So if you were to do this, you would get sine of sine inverse 1.6 upon root 1 minus 0.64, which is equals to 1.6 into 0.46 ka under root. So if you actually solve this, you get this as 0.96. Just do it in the calculator. You get sine of sine inverse 0.96. So the answer is 0.96. That's clever. I didn't thought I could had to use this bullshit ass formula, this fucking bitch ass formula. Okay, so now we have another question here. So f of x is sine inverse root 3 by 2x minus half under root 1 minus x square, and this is given, x's range is given, then f of x is equals to, so we are given this range and we need to solve this one. Okay, so quickly, f of x is sine inverse root 3 x by 2 minus this, उन्होंने साइन इनवर्स के अंदर ही है रूट 3 by 2, क्योंकि तो से साइन इनवर्स x minus y, so I don't have any way to break it out. I could maybe simplify it. I'll simplify the sine inverse 2 root 3 x minus 2 upon 4. ये कुछ तो आ गया, तो दिस इज 2 को तो कॉमन लेगा, तो ये हो जाएगा रूट 3 एक्स माइनस 1 माइनस एक्स स्क्वायर, अब ये अपॉन 2 होल साइन इनवर्स. That's the wrong way to look at this. F of x is sine inverse root 3 by 2 minus root 3 x by 2 minus So now what do we do here? I just wanted to think about it. We have root 3x minus 2. ये साइन के अंदर ही है, ये साइन इनवर्स है, इससे मैं कुछ ले सकता हूँ और शायद इससे भी मैं कुछ ले सकता हूँ. हाफ रूट 1 माइनस एक्स स्क्वायर. I think we'll have to do some substitutions, no? अगर हमने x को इधर sin थीटा लिया तो कैसा होगा? What will we get here? We get sin inverse root 3 by 2 if we put x as sin theta here minus under root 1 minus sin square theta upon 2. Wait, no, this is huge. No, we cracked the code. We have root 3 by 2 sin theta minus 1 over half cos theta. So we already know what this is. This is sin inverse sin. This is sin pi by 6. Sorry, pi by 3. Sin pi by 3 sin theta. Then this is sin pi by 3 sin theta minus cos pi by 3 cos theta. Pi by 3 60 होता है for kind reference. So this is sin inverse, and this is cos pi by 3 plus theta. ये हुआ. So since is you use the property sin inverse, so sin में कन्वर्ट करना है तो उसे ये पूरे एंगल को ये कर सकता है sin pi by 3 plus theta minus pi by 2, है ना? आपकी मर्जी है. इक्वल्स टू sin इनवर्स हो जाएगा pi by 3 minus pi by 2 plus theta, जो कि आएगा sin इनवर्स theta minus 2 pi 3 pi theta minus pi by 6, जो कि इसको साइन में कन्वर्ट करने के बाद आएगा sin थीटा माइनस पाई बाई 6. ये हो जाएगा 2 पाई माइनस 3 पाई अपॉन 6 प्लस थीटा. ये क्या हो रहा है? माइनस पाई बाई 6 प्लस थीटा, तो थीटा माइनस पाई बाई 6. तो ये क्या हो जाएगा? ये हो जाएगा साइन इनवर्स साइन थीटा माइनस पाई बाई 6. Since this is less than pi by 2, this will be theta minus pi by 6. So this is the answer. And what substitution we take? We took x as sine theta. That means theta as sine inverse x. Like theta minus pi by 6 is what we have taken, or whatever substitution have they taken. The answer is sine inverse x minus pi by 6, 16b. Because if you resubstitute the value back, this immediately will become sine inverse x minus pi by 6, which will officially become the final answer. So this should be the answer here, 16b. 16b, 16b, 16 boo. 1b, 16. Yeah, absolutely nailed. So the so now we have this. So the trigonometric equation sine inverse x equals to 2 sine inverse a as a solution for, you know, one of two things here. You have 2 sine inverse a. Sine inverse x is equals to 2 sine inverse a. to sine inverse A. So for this to be equal to 2 sine inverse A, for this to be sine inverse 2A upon root 1 minus A square, ये होना चाहिए A का कंडीशन. मतलब मॉड ए होगा तो ये शायद इक्वल हो, तभी ये इसके बराबर हो सकता है. और you can just do sin inverse x. और कौन सा ऑप्शंस प्रेजेंट है? Some of the options we have here has a solution for, I think 17 is C. We're correct. 1B, 17 is C. It's simple because you can only works when this condition is valid. Okay, so now we're gonna move on to our 18th question. Now we're gonna move on to our 18th question here. So this is the question. Oh, okay. Okay, wow. This is a series. We have r equals to 1 to n sine inverse root r minus root r minus 1 upon under root r times r plus 1. So yeah, I just have to solve this. Let's take a look at this here. Root r minus, so what we can understand of this here is that this is clearly sum and difference of two terms. Okay, so this is clearly sum and difference of two terms. I mean, you do not need anyone to tell you. So root r plus 1. So if I were to just kind of something like this, it's kind of something like this. Maybe just like try and rationalize it. R minus r plus 1 upon, we're gonna have root r plus root r minus 1 to under root r square plus r. Okay, so about this denominator here, this is under root r plus 1, and the denominator here is with r minus 1. So let's look at this. You have root r minus 1 upon under root r plus 1. Actually, let's just shorten this a little bit, this is too much. So root r minus root r plus 1 upon it's r minus 1 on r minus 1 into root r plus 1. If we just were to keep it like this, there's nothing wrong with it, no? Let's keep it like this for now. So what would r is 1? You would get sine inverse 1 minus 0. So you get 1. You have 1 into 2. Sine inverse 1 by root 2 plus sine inverse, we have root 2 minus 1. Okay, upon under root 2 plus 1. Okay, we need to simplify this somehow. So we have root r minus 1 upon under root r times r plus 1. Right, so if you look at it, how do you simplify this? No, the root r square plus r. How are you supposed to simplify this? So this is essentially the multiplication of root r into root r plus 1. Oh, this is a bit of a weird one to break. I want to somehow break this, but I just don't know how am I gonna break this. If root r r minus r plus 1, so we still have 1 upon top. What if it were to take r as something here? Try to put r as tan theta. If I were to put r as tan theta, what do we get? We get root tan theta. Tan theta is 1 upon under root tan square theta plus tan theta. No, that won't. I don't think so. You have to substitute. Maybe if we just break it up, we have root r. Maybe we just split it up like something. Upon root r plus root r minus 1. Oh, so you see the no, yeah, I'm not feeling it. I don't think so. We're getting anything out of this. This is we've hit a dead end. But again, the whole point is how do you just find something that works? We have under root r square plus r. Creating something. If this was root r plus root r minus ऐसा होता. R plus 1. I think it's under root r. We have r minus r plus 1, so you get 1. Let's just take this as 1. Root r minus 1. If I have to square this, ये बस सीधा करके तो सीधा ही आ रहा है. We just want to keep this here. Then let's go something like this. We have r, so you have 1 upon under root r plus 1. If we just rationalize this, so if we rationalize this, we get something like this. हाँ ये वन हो जाएगा ना, ये स्क्वायर करेगा तो रहेगा आर माइनस आर प्लस वन, तो ये वन आ रहा है सीधा। रूट आर आर प्लस वन, no wait, this is wrong. Now if we do this, this is 1 upon root r plus root r plus 1, or potentially the same what we have gotten under root r times r plus 1. Okay, so tell me, what beneficially did we gain out of this? Nothing. Even if say we were to take this 1 and divided by root r plus 1, and this, then we get r अब ये तो ऊपर चले ही जाएगा, ये ऊपर से भी देते हैं root r minus root r plus 1. No, but the whole problem is that कि ये r plus 1 है ही नहीं, तो ये टर्म ही r minus 1 एग्जिस्ट करता है लगता है। Okay, it's a series. It's assuming it should be telescopic. So we have a series here, n equals to 1 to r sine inverse under root r minus under root r minus 1 upon under root r times r plus 1. So the problem here is not the r minus 1, is the r plus 1. ये tan inverse में भी इसे कैसे लिखूंगा मैं भगवान जाने, तो ये एक दिया है, I can rationalize this and make it 10 times worse. It's a good one. So let's just take this. Upon under root r to under root r plus 1. So if you were to rationalize the one on the top, plus root r plus 1 upon, what if you just multiply, divide everything by root r plus 1? Will that work? I don't know. I like would it? Then how to go? So this will be pretty much, it's still the same, but here I could write this r minus 1 upon r plus 1, go r minus 1 into r plus 1 upon plus 1 square, हो जाएगा r square minus 1 upon r plus 1. So this short can also be written as root r upon root r plus 1 माइनस r स्क्वायर माइनस 1 का अंडर रूट अपॉन r प्लस 1. तो रूट r इंटू r प्लस 1 माइनस रूट r प्लस 1 square. Now, no, okay, whoa, we've gone off the deep end here. Like, I don't know. Okay, what do we want here? We want, first of all, we want tan inverse, and what we want below here is a sum of two difference. We have sum of two difference here. What we ideally want in the denominator is this. That means जो भी changes है वो सब इसमें होना चाहिए, न्यूमरेटर में कोई नहीं. तो अगर डिनोमिनेटर को मैंने रूट आर प्लस 1 से डिवाइड किया तो रूट आर माइनस 1, और सपोज मैंने सिर्फ इसे ही डिवाइड किया जो no. रूट आर माइनस 1 अपॉन अंडर रूट आर प्लस 1, जबकि ये 1 माइनस अंडर रूट आर माइनस 1 होना चाहिए था. I mean, is it possible for even it to be like, oh, tan inverse ऐसा होता है क्या? क्या है टेलीस्कोपिक मत आती है, क्या होता था tan inverse 1 माइनस tan hold up. ओके वेट, ये टेलीस्कोपिक बन रहा है चयनित टर्म तक tan इनवर्स रूट n प्लस tan इनवर्स रूट n माइनस 1 So we're left with tan inverse root n minus tan inverse 0. Legit, imagine if C is the answer. Imagine. Yeah, there's no way. Like, even if C is the answer, I'll probably resolve it because like I cannot accept this method. Goes against my morals. Damn. So this is actually right, but we somehow need to figure this out. How did they turn this into tan inverse root r minus 1 upon 1 minus root r minus 1. 1 plus root r minus 1. So that's what we have to figure out here. The telescopic we're getting here is weird, but it's something. It's the meaning upon. So how do you make this? So this is fine. So it's about this. So you have root r minus 1 upon under root r into r plus 1 upon, if you just multiply, divide this by r minus 1. Yeah, I'm rationalizing this. So this will become under root r by r minus 1 square minus 1. How do you break this, bro? If the method turns out to be something stupid, no, like I'm gonna be the one that I'm actually just gonna be really mad if the method just turns out something stupid. So this is just rationalized and found it. Okay, here in the solution it's written here directly, but I think question 19, where we have sine inverse x is equals to theta plus beta. And sine inverse y is equals to theta minus beta. Sine. I mean, this is just a basic question. X is going to be sine theta plus beta, and y is going to be sine theta minus beta, which is sine theta cos beta plus cos theta sine beta. This plus cos theta sine beta. So this is going to be sine theta cos beta minus cos theta sine beta. So 1 plus xy will be equals to 1 plus this into this, which it's pretty much the same here. So here you have 1 plus sine square theta cos square beta minus cos square theta sine square beta. So theta minus sine square beta is this. Oh, we get this. It's pretty dumb, to be honest. थीटा माइनस बीटा, एक थीटा को प्लस बीटा दिया है, थीटा माइनस बीटा है, साइन ऐसा ही होगा. So you have 1 plus xy equals to 1 plus sine theta plus beta into sine theta minus beta. 1 plus sine A sine B. If I multiply and divide by 2, okay, so here So here we are going to be using defactorization. So this is going to be 2 plus 2 sin A sin B, which is plus cos A minus B thus cos A plus B upon 2. Two plus cos plus beta, तो ये cos 2 beta plus cos theta plus beta plus theta plus cos 2 theta by 2. इसका आंसर क्या है? सिंपल, ये है 1 प्लस cos अरे नहीं 1 प्लस 2 cos square beta minus 1 plus 2 cos square theta plus 1. तो 2 माइनस 2 तो क्या हो गया? देखो 2 cos square beta plus 2 cos square theta by 2. तो आ गया आंसर ही cos square beta plus cos square theta. ये आंसर cos square beta plus cos square theta cos square beta. हाँ 19 का C है, 19 का C, 19C 19C ITF. 19 का साइन स्क्वायर थीटा प्लस कॉस स्क्वायर बीटा. 19 का ओके. Okay, so we are right. To clear out space, it's time for a big one, baby. Now we have a question. Which is tan pi by 4 plus half cos inverse plus half cos inverse A by B plus tan pi by 4 minus half cos inverse A by B. Take cos inverse A by B को x ले ले तो A by B equals to cos x. थीटा क्या है? ये हो जाएगा एडजेसेंट one hypotenuse. The length is b square equals to x square plus a square on it, bro. Square minus a square हो जाएगा ये. Under root b square minus a square. So tan x is equals to opposite upon adjacent. So this से बदल हो जाएगा tan pi by 4 plus x by 2 plus tan pi by 4 minus x by 2. So this will become tan a plus tan b tan a tan b. One plus tan x by 2 and it's a no here very much. So let's just look at this point again. Solder is spread nuts for sure. So I'm going to take this entire thing as x. So it is tan pi by 4 plus x plus tan pi by 4 minus x. This is what 1 plus tan x upon 1 minus tan x plus upon tan a minus tan b, tan a minus tan b, 1 plus tan square x plus 2 tan x plus 1 minus 2 tan x plus tan square x upon 1 minus tan square x आ रहा है, जिसका वैल्यू कितना है 2 tan square x plus 2 upon 1 plus tan x 1 minus tan x 2 tan square x plus no. क्वेश्चन क्या है, tan pi by 4 plus half cos inverse a by b plus tan pi by 4 plus half cos inverse a by b. It's definitely more exhaustive than expected. Alright, so we look at this question here. What do? We take cos inverse a by b as x. I think that's what, or phi. Cos phi is a by b. Phi adjacent hypotenuse. Tan phi opposite upon adjacent. इसको अभी के लिए तू tan pi by 4 प्लस इसको phi लिया तो प्लस phi by 2 प्लस tan pi by 4 minus phi by 2. I think इसका आंसर ये है 2a by b. Cos 2 theta is equal to a by b. The cross multiplication was done. Not 5 by 2. I think what we could have done is you just take this entirety as what you want, x, take this as x. So you have cos inverse a by b equals to 2x. So cos 2x equals to a by b. I'll just keep that in mind. And let's try and remove it in their terms, no? So this is tan. So you have 1 plus tan x. One minus tan square x. Having 1 plus tan square x plus 2 tan x plus 1 plus tan square x minus 2 tan x. This is 2 1 plus tan square x 1 minus tan square x Yeah, and the formula for this is 2 into 1 by cos 2 theta 2 cos 2x. I just didn't see it. I have been the idiot all along, sir. Just too short-sighted to see it. This is the next question that we have on our list, ladies and gentlemen. If x belongs from minus pi by 2 to pi by 2, find tan inverse tan x by 4 plus tan inverse this. Done. Tan inverse tan x by 4 plus this monstrosity or whatever this is. इसकी रेंज दी और ये ढूंढना है. अच्छा इसकी वर्क. tan inverse 1 by 4 tan x. तो immediately ये x by 4 हो जाएगा plus tan inverse this 3 sin 2x upon 5 plus 3 cos 2x. What do we do here? In this type, in these types of questions, what one can do here is we could maybe just write this as 2 plus 2 cos x plus cos. You can write 2 cos 2x. We could write this as 2 cos 2x plus cos 2x here. I think that would be perfectly fine. Right, we can just write this as maybe something like this, or maybe we could just write this as 5 plus, where is this, 5 cos x, no, something, no, sorry, 5, we got 5 plus 5 cos 2x minus 2 cos 2x, something like this, and then this is just 5 1 plus cos 2x, so cos 2x 2 cos square x minus 1, so this is 10 cos square x. Don't miss that there is more than that came from. तो बेसिकली में cos में एक नीचे इक्वेशन बन रहा है, ऊपर साइन में भी एक चाहिए. This is not looking good here. On tan inverse 1, we have 5 plus 3 cos 2x in the denominator, and we have 3 sin 2x in the numerator. This one, I can tell you, this one will most likely be x by 4. On the assumption, going off assumption here that this is x by 4 plus tan inverse this 3 sin 2x upon 5 plus 3 cos 2x. I divide this whole thing by cos 2x here, so so now we're going to only talk about this specifically. 3 sin 2x upon 5 plus 3 cos 2x. So this could be 3 tan 2x. 3 tan 2x upon 5 plus, or we have one idea. This is sin 2x, no? It's a bit crazy. 3 sin 2x upon 5 plus 3 cos 2x. 3 into 2 tan x upon this, having a scroll here, something like this you could do. This is just 6 tan x upon 1 plus tan square x by 2 upon 5 plus 5 tan square x by 2 plus 1 minus tan square x by 2 upon 1 plus tan square x by 2. Obviously this will get cut, so this will become 6 tan x upon 5 plus 4 tan square x by 2. If 6 tan x upon 3 plus, so something like this in tan inverse. Oh, we're just getting nothing right now. Holy, this is nuts. 1 second. Okay, so after a little bit of consideration, we've kind of found what we want to do with this. So you could just put this as 3 into 2 tan x upon 1 plus tan square x, and this is just 5 plus 3 into 1 plus tan square x, 1 minus upon 1 plus tan square x. So this is already just 6 tan x upon 1 plus tan square x by 2, 1 plus tan square x upon 5 plus 5 tan square x by 2 plus 3 minus 3 tan square x, I mean tan square x ये वो छोड़ना, upon 1 plus tan square x by 2 equals to 6 tan x upon 8 minus 2 tan square x, which is equals to 3 tan x if you divide it by 2, which is 4 minus tan square x. Okay. Let's get up. Let's get up and around, shall we? Oh god. So what are we getting here is tan inverse tan x by 4 plus we're getting tan inverse 3 tan x upon 4 tan 4 plus tan square x. If you actually solve this, you will get tan inverse 16 tan x plus tan cube x upon 16 plus tan square x, and then इससे obviously tan x कॉमन निकालेगा, tan inverse tan x, and the answer is x. So that is the answer. Nice. That's ITF. So that's our solving done. Hope you guys enjoyed.